IoT-based condition monitoring of transformer. Abstract transformer is an important asset in transmission and distribution network. Its operation and control are important aspects, which determine the reliability and quality of power supply. As large number of transformers are spread over wide area in the present power system, it is difficult to monitor the condition of each transformer manually. Therefore, development of condition monitoring system for transformers is done. This condition monitoring system can monitor several parameter status of transformer in real-time aspect, with automatic data acquisition. This paper presents design and implementation of IoT-based mobile embedded system to monitor the temperature of transformer oil and detection of various gases like methane, carbon monoxide, hydrogen, acetylene, ethane, etc. This monitoring system is programmed with some predefined instructions to check the abnormal conditions based on their established values. This remote monitoring system using IoT will help to identify problems before any failure occurs. Different faults can be identified from the data obtained using dissolved gas analysis, DGA, which is helpful in detecting the condition of transformers for its long tenure. This system can be an advanced step in automation, which does not depend on manual testing and human dependency. As it is a wireless communication system, it is cost-effective. Temperature monitoring provides fundamental protection for the transformer by preventing operation in overheated condition, as overheating leads to insulation damage and reduces transformer life expectancy. Thus, condition monitoring offers improved transformer protection. Keywords: transformer oil, temperature, dissolved gas analysis, IoT, Arduino. 1. Introduction. Electricity plays an important role in our life. Every moment of our life depends upon electricity. Electricity has several components and equipments, which help human to transfer and regulate the distribution according to usage. The most crucial equipment of transmission and distribution of electric power is transformer. Transformer is a device used in the power transmission of electrical energy. Transformer works on the principle of electromagnetic induction and mutual induction. The transmission current is AC. Their function is to increase or decrease the supply voltage without change in the frequency of AC between circuits. Transformers are essentially required in various fields like power generation grid, distribution sector, transmission, and electric energy consumption. Condition monitoring of transformer is the process of acquisition and processing of data related to various parameters, to predict and prevent the failure of a transformer. This can be done by observing the deviation of the transformer parameters from their expected values. This will help and guide the utilities to optimally use the transformer and keep the equipment in operation for longer period. The proposed project presents design and implementation of embedded system to measure temperature and different gas detection. This is possible by using online measuring system using Internet of Things, IoT, for fault condition alert, with Arduino microcontroller and sensors installed with transformer. Whenever any change occurs in the condition of transformer oil exceeding the permissible range, the sensor detects these changes and there is an alert via push messages. It also detects the faults such as electrical faults, thermal fault and overheating of oil. This paper includes the description of components, block diagram, and the results obtained. 2. Proposed system. A typical condition monitoring system for a transformer is capable of monitoring various components like oil temperature, gas in oil, moisture in oil, oil level, voltage, current, etc. The main objective of this paper is to design and implement an embedded mobile and IoT-based system to measure oil temperature and dissolved gases like carbon monoxide, hydrogen, and methane using sensors. 3. Hardware requirements. 3.1 LM35 Temperature Sensor. LM35 is a temperature sensor that outputs an analog signal, which is proportional to the instantaneous temperature. Temperature in Celsius is obtained by easily interpreting the output voltage. LM35 can measure from 55 degrees centigrade to 150 degrees centigrade. The accuracy level is very high if operated at optimal temperature and humidity levels. The input voltage to LM35 can be from plus 4 volts to 30 volts. It consumes about microamperes of current. 3.2 MQ2 sensor. MQ2 sensor contains a sensing element, mainly aluminium oxide-based ceramic coated with tin dioxide enclosed in a stainless steel mesh. It is an electronic sensor used for sensing the concentration of gases such as methane, carbon dioxide, etc. The preheat duration is for 20 seconds. It is used as digital and analog sensor. The sensitivity of digital pin is varied using the potentiometers. 3.3 LCD display. Liquid crystal display screen is an electronic display module and has a wide range of applications. A 16x2 LCD display is a very basic module and are commonly used. A 16x2 LCD means it can display 16 characters per line, and there are 2 such lines. LCD modules are very commonly used in most embedded projects, the reason being it is program friendly and it is economically. 3.4 Wi-Fi module. The ESP8266 Wi-Fi module is a SoC, Security Operations Center, with integrated TCP/IP, Transmission Control Protocol/Internet Protocol stack that can give any microcontroller access to your Wi-Fi. The ESP8266 is capable of either hosting an application or offloading all Wi-Fi networking function from another application processor. 3.5 MQ7 sensor. Sensitive material of MQ7 gas sensor is SNO2, which with lower conductivity in clear air. It makes detection by method of cycle high and low temperature, and detect carbon monoxide CO when low temperature, heated by 1.5 V. MQ7 gas sensor has high sensitivity to carbon monoxide. The sensor could be used to detect different gases contain CO. 3.6 MQ8 sensor. A sensitive material MQ8 hydrogen gas sensor module H2 alarm detection use in clean air low conductivity tin oxide. This sensor can detect a wide range of hydrogen gas, city gas in particular, is a low-cost sensor for variety of applications. Suitable for home or industrial hydrogen leakage monitoring devices. 3.7 Arduino Uno. Arduino Uno is a microcontroller board based on ATmega 328P. It has 14 digital input/output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, USB connections, a power jack, an ICSP header and a reset button. It contains everything needed to support the microcontroller. Arduino is an open-source electronics platform based on easy-to-use hardware and software. 4 Software requirements. 4.1 Arduino IDE. Arduino IDE is an open-source software that is mainly used for writing and compiling the code into the Arduino module. This software makes code compilation too easy. It is easily available for operating system like Mac, Windows, Linux, and runs on the Java platform that comes with inbuilt functions and commands that play a vital role for debugging, editing, and compiling the code in the environment. The main code, also known as a sketch created on the IDE platform, will ultimately generate a hex file which is transferred and uploaded in the controller on the board. 4.2 ISIS Prathyusha. The Prathyusha Design Suite is a proprietary software tool suites primarily for electronic design automation. Mainly electronic design engineers and technicians to create schematics and electronic print for manufacturing printed circuit boards use the software. Prathyusha is used to simulate, design and drawing of electronic circuits. The Lab Center Electronics invented it. Prathyusha is a complete development platform product concept to design completion. Its advantage are intelligent principal layout, hybrid circuit simulation and accurate analysis, single chip software debugging, and peripheral circuit CO simulation, PCB automatic layout and wiring. 5 Working. A typical condition monitoring system for a transformer is capable of monitoring various components like oil temperature, gas in oil, moisture in oil, oil level, voltage, current, etc. The main objective of this paper is to design and implement an embedded mobile and IoT-based system to measure oil temperature and dissolved gases like carbon monoxide, hydrogen, and methane using sensors. A predefined program uploaded to the Arduino is calibrated the given input values and it provides the necessary output. This work includes the process of monitoring of transformer oil's temperature range and the gases present in the oil as well as transformer tank. The sensed values are given to the Arduino. The values given by the sensors are measured and compared with the nominal value predefined in the program in the comparators. If the measured value varies, the system will send an alert to the concerned person with the help of Wi-Fi module, and as an physical indication the buzzer gives beep sound and also LED bulb glows. The programmed output is displayed through a local display LCD screen. The same output is also transmitted through the Wi-Fi module to the Internet server and then to the mobile application BLYNK as programmed in the Arduino. Data will be saved and can be used for the further analysis. The GSM modem is used as a short message server device that transmits parameters as an SMS. By the use of software to store and perform the dissolved gas analysis of the measured data, the information on the state of health of the transformer and alarms raised when measured values exceed appropriate limits can be provided to the operator. 6 Results and discussions. Case 1. When temperature is normal and when the sensors do not detect the gases methane, carbon monoxide, and hydrogen, the result display is shown below. Case 2. When the temperature was raised beyond the permissible values and when gases such as methane, carbon monoxide, and hydrogen are detected by sensors. Results are displayed as shown below. Conclusion. This study gives remedies from difficulties of determining fault occurring causes in transformer and it overcomes the drawbacks of previous working methods. The project focuses mainly on the efficiency of monitoring process of transformer by using wireless communication that eliminates the use of large cables which are of high cost, low reliability, and maintenance. The main goal of the project is to design and construct an Internet of Things, IoT, based transformer monitoring system which can display real-time states in transformer. After the construction of the device, the system was tested successfully. That is, the device can monitor the condition of transformer and send data accumulated from the sensors through the Wi-Fi and displayed over the IoT platform. All parameters that are critical and have exceeded their threshold limit can be sent through SMS for immediate action to be taken. It continuously monitors the parameters throughout its operation with high accuracy. Future scope. We can design a special circuit which can trip the circuit breaker automatically in case of fault before the SMS reaches the mobile operator, which makes the operation even faster. This system finds a big scope in transmission lines by using other communication protocols like LoRa, RF 434 MHz etc. Using genetic algorithm in determining best sensor readings or faulty sensor readings can be helpful in calculating accurate health index during faulty sensor situations. This system can be expanded to big campuses or societies with many acute substations which can be operated and monitored remotely. This system can help in reducing post-fault clearing time in distribution network. This system can be expanded to 3-phase transformer, which will display more accurate health indices.